Alright, let's get started with Lesson 4 on isotopes. Now this lecture video is just going to give us a brief overlook of what isotopes are and some principles behind them. But in class we're going to go into a lot more detail into them and even do some laboratory work with them. Alright, so in general this is an important statement. The number of protons in the nucleus of an atom determines the identity of the atom. The number, the proton, one proton more or one proton less, and you have a completely different atom. So the number of electrons and the number of neutrons does not affect what the atom is. Only the number of protons determines that. So the reason why carbon is because it has 6 protons. The reason that hydrogen is because it has 1 proton. All right, so it's the proton number that determines the identity of what atom we're looking at. All right, so here we have some different atoms here. We have beryllium atom, fluorine atom, and carbon atom. And what makes them unique from one another is their number of protons. So if you look at your periodic table, the number of protons, or the atomic number of beryllium, is 4. Okay, so that means it should have 4 protons, 4 positive charges in the nucleus. All right. For fluorine, the reason why fluorine is because it has an atomic number of 9, which means it has 9 protons in its nucleus. Carbon, same thing. It has a total of 6 protons in the nucleus. So carbon, no matter what, will always have 6 protons, or it can't be a carbon atom. Fluorine must have 9 protons, or it cannot be a fluorine atom. And beryllium must have 4 protons in order for it to be beryllium. Now the number of electrons could change. The number of neutrons could change. But as long as the proton number stays the same, it is that particular atom. For instance, carbon. What if carbon added more neutrons? Would it change the fact that it's carbon? No, because as long as the number of protons remain constant, it doesn't matter how many neutrons are in the nucleus, it's still carbon as long as it has 6 protons. Same thing with electrons. If we lose or gain electrons, it doesn't matter. It will still be carbon if it has 6 protons. All right? Get the idea? I hope. All right, let's get into the definition of isotope then. So by definition, atoms of the same element that have the same number of protons but differ number of neutrons and mass numbers are isotopes. All right? So again, atoms of the same element that have the same number of protons but they have different number of neutrons and mass numbers are considered isotopes of each other. Important definition to understand. So let's look at this. Here are 3 different isotopes of carbon. Now, there are all carbon atoms. Why do we know they're carbon atoms? Because they have 6 protons, every one of them. And as long as you have an atom with 6 protons, they are carbon atoms. So, if you look at these individual nucleuses, you should see that there are 6 protons. We're going to call these our protons. Sorry, the black ones I think are actually, the darker ones are actually the protons. 6 protons in the nucleus of these atoms. So the lighter circles are going to be our neutrons. And if you look at the next isotope, again, 1, 2, 3, 4, 5, 6 protons, and so forth. So if you look at these atoms, what are the only thing that's changing about these atoms in their nucleus? That would be the number of neutrons. So the difference in these 3 atoms is not their number of protons, but their number of neutrons, as you can see here. So the isotope carbon-12 has 6 protons and 6 neutrons. The isotope carbon-13 has 7 neutrons, 6 protons, and carbon-14, 6 protons and 8 neutrons. They are isotopes because they all have the same number of protons. They are all from the same element, but they are different in their number of neutrons. Therefore, they are considered different atoms of the same element. And those are isotopes. All right? Now, you'll also see that there's some percentages here. What are those percentages for? Well, it tells us how abundant these particular isotopes are. So, for instance, carbon-12 is the most abundant isotope of carbon. 98% of the carbon atoms out there are going to be carbon-12, whereas less than 0.1% of the carbon atoms out there in nature are only carbon-14. And in between that would be 1.1%, which would be carbon-13. All right, now those percentages are important, and we will spend a lot more time dealing with percentages of different isotopes in time. All right? All right, so a little bit more on isotopes. We know that there are 118 different kinds of elements on the periodic table. And all elements on the periodic table are going to be or have isotopes or isotope variations. So we need basically a standard way to write those isotopes. So this diagram that we have here kind of shows that idea. So the X represents the element symbol, all right? And then the Z stands for the atomic number. Anytime you see a Z, it stands for the atomic number, and it's always written in the lower left-hand corner, as you see here pictured. And then up here we have the mass number. So the mass number symbol is A. And what exactly is the mass number? Well, we basically take Z, which is the atomic number, and we add that number to the number of neutrons. So you can essentially say that the mass number is the number of protons plus the number of neutrons. And that gives us what A is. Okay? So for instance, let's go back to our previous diagram here of our 3 carbons. So let's look at carbon-12 and kind of get the idea of this. Now, why do we call it carbon-12 in the first place? Well, the 12 represents the mass number. That's the mass number of our atom. All right? And so carbon-13 has a different mass number. Its mass number is 13, and carbon-12 or 14 has a mass number of 14. So remember, what is the mass number? Well, it is the total number of protons and neutrons added together. All right? So we name isotopes based on the mass number that they are and the element that they're made up of. So carbon-12 is made up of a total of 6 protons and 6 neutrons. So therefore we call it carbon-12 because 6 plus 6 is 12. Whereas carbon-13 is carbon-13 because it comes from a carbon element, but it is composed of 6 protons and 6 neutrons. When you add that together, you get 13. Carbon-14, 6 protons and 8 neutrons added together, you get 14. So that's our mass numbers. All right? So hopefully that kind of gives you an idea of mass numbers and how we name these isotopes. Now they're symbols. Okay? So let's look at carbon-12. Carbon-12, it's a carbon atom from the element carbon, so it's going to have a symbol of C. All right? In the lower left-hand corner, remember, goes the atomic number. So the atomic number of carbon is always 6, so we write a 6 there. And then up in the upper left-hand corner is the mass number, carbon-12, like so. And we can do that for carbon-13, 6 and 13, and carbon-14 would be 6, and 14, just like so. All right, so that's how we use the symbol and represent these isotopes symbolically as well as their names. All right, so again, by definition, the mass number is the total number of protons and neutrons in the nucleus of an atom. All right, now we can use the periodic table to determine the number of protons, right? That's the atomic number, so that would be so easy. All right, to find the number of neutrons, then you would have to take the mass number and subtract the number of protons from it to give us the number of neutrons. So let's go back to our carbon, for instance. So let's say carbon 12. All right, we know that it has 6 protons and a mass number of 12. So the mass number being the total number of protons and neutrons, if we take the number 12 and subtract it from 6, that should give us 6 neutrons. All right, for carbon 14, if we take our 14, our mass number, and subtract it from our number of protons, that gives us 8 neutrons. So from the mass number and the atomic number, we can find the number of neutrons for any atom. Alright, so what we're going to do is do a little activity here. We're going to fill out this table for these particular isotopes. So we're looking at oxygen 16. That tells us that the 16 again tells us that it has a mass number of 16, or a total of 16 protons and neutrons. So what is the atomic number for oxygen? Looking at your periodic table, you should find that the mass number for oxygen, or the atomic number for oxygen, is 8. All right. The mass number we just said was 16. The number of protons is equal to the atomic number. Now the neutrons. How do we get the neutrons? We take the mass number and the proton number. We subtract the 2, and we get the number of neutrons, which in this case would be 8. 16 minus 8. Now what about the electrons? We haven't really even discussed the electrons here. Well, atoms are neutral. So because they're neutral, they have to have the same negative and positive charge. So if we have 8 protons, or 8 positive charges, that means we have to have 8 negative charges. So the electron number is going to be the same as the proton number in a neutral atom. And so we're going to consider all of these isotopes neutral. So the proton and electron number should be the same. Okay, let's look at sodium. Sodium has an atomic number on the periodic table of 11. It has a mass number 23, and therefore a proton number of 11. So 23 minus 11 will give us our neutron number, and that would simply be 12. How many electrons? Should be the same number of protons, 11. So now let's look at iron 56. Iron has an atomic number on the periodic table of 26. The mass number is 56. 56 minus 11 protons would give us a total number of 26. Wrote that wrong. Back up. It has 26 protons. So 56 minus 26 is going to give us a number of 30 neutrons. How many electrons? It should have 26, the same number as protons. All right, sulfur. How do we deal with sulfur? Well, sulfur 32 has an atomic number of 16, mass number 32, 16 protons. 32 minus 16 gives us the number of neutrons, and in this case, that would be 16. And we have 16 electrons. Okay, finally, argon 40. Argon has an atomic number of 18. It has the mass number of 40. Again, 18 protons, so 40 minus 18 gives us 22 neutrons, and it has the same number of electrons as protons, which is 18. Alright, so that's kind of how you deal with that. This is a skill that you need to be able to do. I'm going to give you some homework problems to practice this skill a little bit, although most people are familiar with doing this already, but just to double check and to make sure that you can do this, so when you get to the AP or IB test, there's no question about how this all works. Alright, so that gives you a basic beginning or understanding of isotopes. This is all that I'm going to talk about in this lecture video on isotopes. The rest will be discussed in class. So that is it for now.